All right, so in the previous videos, we looked at hypothesis testing using z-tests and t-tests, and now we're going to look at the proportional z-test for one variable. So here's a situation where June believes that 50% of first-time brides in the United States are younger than their grooms. So this is your major indicator that we are going to use a proportional z-test. Now, that means that our p sub 0 is going to be 50%, or 0.5. Now, you might be thrown off by the word are younger than, like as that is one of your inequalities, but that's really not the focus of the problem. Our focus of the problem is to test to see if 50% is correct. So she performs a hypothesis test to determine if the percentage is the same or different from 50%. Well, you know your null and alternative hypothesis right from that statement. The null hypothesis is going to be checking to see if our 50% is correct. Now, the alternative hypothesis, since it says same or different from, is going to be not equal to. So this is going to be a two-tailed test. Now, June samples 100 first-time brides, so this is our n, and 53 reply that they are younger than their grooms. So x is equal to 53. In binomial problems like this, we are going to have an n, which is our sample size, and an x, which is our target number that we found from the sample. And we're given that we want an alpha of 0.10. You can write it as 0.1, or I just wrote it as 0.10 stylistically, because our confidence interval is 90%. So let's go to step 2. Now step 2 has us check to see if n times p times q is greater than 10. If this is the situation, which means that we have a big enough sample size, then we can assume normality. If this isn't greater than 10, then we have to use the binomial CDF for our target x, and use a binomial distribution rather than the normal distribution. So we're going to look at our n, and our n in this case is 100. We're going to look at our p, in this case it's 0.5, and q is the same thing as 1 minus p, or the complement of p. So in this case, 50% subtracted from 1 is 50%. So 100 times 0.5 times 0.5 is equal to 25, and since 25 is greater than 10, we can assume normality. Our p prime can belong to the normal distribution, and our normal distribution is going to have our average of p hat, and our standard deviation is going to be the p hat times q hat divided by n square rooted. Now you don't need to worry about this calculation here, because the calculator will do this for us. In step 3, let's access the one proportional z-test. So turn our calculator on, click the stat button, click over to the tests menu, and you can see that the one proportional z-test here is my option 5. You might have a different option for that. If you click enter, then it asks for your p naught. In this case, this is our 0.5. Our x, we found that 53 out of 100 people said that their grooms were younger than they were. So a lot of times we are going to check the not equal to, but always be careful about which one you check, because this goes back to your alternative hypothesis. Your alternative hypothesis is not equal to your null hypothesis, so we are going to now click on draw. And let's take a look at our two-tailed test. All right, it looks like there's a lot of shaded area here, but let's write down our z-score, and let's write down our p-score, or p-value. Okay, so our z is 0.6, which is not a percentage. This is how many standard deviations you are away from the norm. And our p, or p-value, and I may want to write down p-value here so you don't get confused with the other letter p's in this problem. Our p-value for the problem is 0.5485. So if we take a look at that picture on that z normal curve, you can see that we have a lot of shaded area over here and a lot of shaded area over here. And I'm going to plant my flag at 0.6 since it was above 0 here. So here's my flag at 0.6. And that 54.85% is the total of all the space inside of both shaded regions, which is actually over 50%. So it's actually going to be easier to be in the shaded regions than it will be outside of the shaded regions. So did you see a rare event? Did you, when you asked those 100 brides, did you get a rare event? Was your p-value less than or greater than your alpha? And remember, your alpha was a pretty generous 10%. So your p-value was 0.5485. So it is definitely bigger than 10%. Your chance of making a mistake was a lot lower than your chance of landing where you did. So if the p-value is high, you let the null fly. Do not reject. Do not reject. So let's scroll down here to step 5. If you scroll down to step 5, then we can make our conclusion here. And again, this first part has to be written down in the paper pencil test. Since p is greater than alpha, sorry, that looked like infinity there. I need to make that a little bit better of an alpha. There we go. Since p is greater than alpha, we do not have sufficient evidence to reject the null hypothesis. Okay? So please make sure you have the inequality down when you do your paper pencil copy, because you need to tell me why you've chosen that you did. Okay, so for our last example, the final problem of hypothesis testing, we're going to look at this consumer group that suspects that the proportion of households that have 3 cell phones is 30%. So that's our null hypothesis. Our null hypothesis is that p sub 0 is going to be equal to 30%, or 0.3 or 0.30 being stylistic. A cell phone company has reason to believe that the proportion is less than 30%. So there's our alternative. P sub 0 is less than 0.30. So this is a left tail or one tail test. Before they start a big advertising campaign, they conclude a hypothesis test. So in step 0, we learned that p sub 0 is equal to 30%, and they surveyed 150 households, and they found the result that in those 150 households, 35 of the households have 3 cell phones. So we now have what we need to solve the problem. But in step 2, we do need to check to see if we can assume normality. So what we have is n times p times q, and we got to make sure that's greater than 10. This is one of the rules of thumbs that you can use to assume normality. Now luckily we had a really big size for n. If that n isn't big, then this number may fail here. And the probability of having a cell phone, or having 3 cell phones, would be just 30%. And that means the q would be the complement of that, which is 70%. So 150 times 0.30 times 0.70 is 31.5, and that is greater than 10. So since 31.5 is greater than 10, assume normality, which means that our p prime belongs to the normal distribution, and that normal distribution is our success of p hat and our standard deviation of p hat times q hat divided by n. And again, the calculator takes care of this for us, so we don't have to. Hooray! So let's look at step 3. Let's get the calculator back. And let's turn it on and go back to the Stat button. Click over to Tests. Click down to one proportional z-test, so hit the Enter button there. Now our P0 is 0.3. Our X is, let's see, 35. And our N is 150. Okay? So we want under, so we're going to go less than, click on that, and then we're going to go to draw to make sure we have the right picture. I usually don't even bother with calculate because this gives us everything we need. We got our z-score of negative 1.7817, and we have our p-value at 3.74%. So let's now draw that picture. Oh shoot, that should be step 4. I'm sorry, got ahead of myself there. Let's write down those two values. The z equals negative 1.7817, and the p-value is 0.0374. Now let's draw the bell curve here. Okay? Now, this is 0 standard deviations away from the norm. We have a shaded side over here, and we're going to plant our flag at negative 1.7817, which is the z-score telling me that I'm almost 2 standard deviations below the norm, and I know that is very, very unlikely. I mean, 2 standard deviations away from the norm is not normal. You know, 1 standard deviation away from the norm is normal. Like, so here's your bound of normalness, right? So these are normal numbers. Anything outside of negative 1 and 1 to the right and to the left of that is considered weird. So this percentage, this p-value here, I mean, this is only 3.7% chance of landing in that zone. So how is the p compared to alpha? Now, what we chose in this case is no alpha was chosen. You'll look back at the original problem. Do you see any alpha in the original problem? It's not 30%. If no alpha is given, you must default 5%. That's the default, okay? If no alpha is given or no confidence interval is given, default to 5%. Now, how does the p-value compare to that? 0.0374. Well, look at that. It is less than. So we reject the null hypothesis, which means that in our statement, step 5, your statement, since p is less than alpha, and you need this for the paper pencil test, we have sufficient evidence to reject the null hypothesis. All right. Now, for my final little bonus cut of this video, I want to bring the calculator back. I want to bring the calculator back to this idea of step 2 for these problems. When you had to multiply by n, and in this case it was 150, times p, which was 30%, times q, which was 70%, which gave us 31.5. Now, what would happen if I dropped the number here from 150 to 100? Well, now we're getting closer and closer to that danger value of 10. Okay, so if I click second enter one more time, okay, and I change this instead of to 100, I change it to 50. Uh-oh, looks like my sample size is getting too low to assume a normal distribution. Let's continue going from here. Let's go second enter and say, what if I only interviewed 25 people? If I only interviewed 25 people and 53 out of 100, or sorry, there's a smaller ratio here, of course, since we don't have the correct x out of the total there. Now I would have a small number less than 10, and what I would have to use instead is I would have to use not the normal test. I couldn't actually use this this one proportional z-test. If my number was less than 10, I'd have to go second vars, and I'd have to go to my binomial CDF. Binomial, I went to Poisson by accident. Let me try that again. I have to go to binomial CDF. Okay, and then it would tell me that I'd have only my 25 trials, right? My p-value here would be the 0.3, and my x-value would be how many out of those 25 had 3 or more cell phones, and let's say it showed up as like 10. Okay, and then this would give me my percentage that I would go against my alpha, and in this case this would be highly 90% is highly likely, so that means we would not reject the null hypothesis, because if the p is high, the null must fly. So this is what happens. This is your bonus cut. This is what happens when you do step 2 of this problem and you get a situation where it's not greater than 10. You can't assume normality. You've got to use a binomial distribution, and the binomial CDF takes care of that for us. All right, well, thank you for watching. There was a lot to do in these series of videos, but hopefully you got enough examples that doing the homework should be easy peasy. Thank you for watching.